All right, we're going to subtract polynomials, but I want to review adding polynomials first since it's been a little while. So if I have two polynomials, there's two terms here, so that's a binomial and a binomial. And when I'm adding, basically all I do is I look to find the like terms. Okay? And you really don't even need the parentheses there. We could just write it 3x plus 5 plus 2x plus 7. And then I look for my like terms, and I combine them together.
Right. So
2x and 3x and 2x make 5x. And the 5 and the 7 makes 12, right? Okay. Subtracting polynomials is a little different, but it has similar rules, okay? So this up here, we'll read what this has to say. Subtracting polynomials using algebraic rules of changing subtraction to adding the opposite. So we're going to do a similar idea with this, but we're going to change it to adding the opposite. To change subtracting polynomial problems to adding the opposite, reverse the sign of each term in the subtracted polynomial, drop the parentheses, and combine like terms. Subtraction of polynomials, like addition, can be done vertical and horizontal. So we're going to do it in the horizontal format first. Okay, so we're going to go 4x cubed plus 2x squared plus 5 minus, I might have to go little here to make sure I can fit it in there, x to the third minus 7x plus 1, okay? So that we don't forget that we're subtracting, we're going to add the opposite. We could just say that, look, these are like terms. And I have a 4x to the third and x to the third. So I have 4x to the third minus, so I could say it's 3x to the third. But when we have this minus that's right here, it gets kind of confusing. And sometimes we forget that we're subtracting. And so what's better to do is to make all of these the opposite of what they are. We write this 4x to the third plus 2x squared plus 5. And we say this is a minus x to the third. This minus and minus become a plus 7x. Boy. And then this minus and plus become a minus 1. Then we just treat it like it was the adding polynomials from before. So these are my like terms. So now I have a negative 1 and a 4, so that is a 3x to the third. This doesn't go with anything, so we just bring that down. And we bring this down because it doesn't go with anything. But these do go with each other. And I have a 5 minus a 1, which makes 4.
Wait, you mean equals 4?
Well, this, yes, this 5 and this minus 1 equal 4.
Oh, okay. Well, I saw the plus 4.
I'm sorry, so we add 4 at the end because it's a positive.
Right.
Okay? So let's do another one. Let's do the horizontal format. That was the horizontal. Let's do another horizontal format. All right, here's our next problem. We're going to do the same thing. We're going to pretty much, it's like distributing that negative to everything there. Okay, we're going to give it there. So we're just going to rewrite this. Then we have a minus, then this next one, let's take all that off. All right, so then if I do that minus there, it's going to be a plus 5y squared minus yz, and then minus makes a plus 7z squared. Now where's our like terms? Is there a like term with this 10?
No. Yes, there is right there.
Yes. So then I have a negative y set to the second and a 5y to the second. What does that make?
A negative 10y to the second?
Yes, negative 10y to the second and a positive 5y to the second.
Negative 5y to the second.
Good. Do I have anything with that one?
Yes, this one right here.
Okay.
Which would make 5y z.
Okay, and then is that a positive or a negative?
Positive.
Okay. Do I have anything that goes with this?
No. Well, the z squared.
Yes. Okay, so what does that become?
Then it becomes negative 35?
We're just gonna.
Oh, I thought that was a 35.
I understand.
Okay, so 2. No, I'm sorry. 4?
Yes.
Yeah, 4.
Positive or negative?
Positive. Oh, yeah, that is squared. I didn't see the squared there.
Sorry, that's a square. Okay.
Okay. And that's how you do that, right?
And that's how you do it. We're done.
Oh, that's not
All right.
bad.
And they mentioned a vertical format, but didn't. Oh, they have it down here. I understand. So let's do that same one, but we're going to do it in the vertical format. We had that 10y second plus 6yz minus 3z squared. We're going to go back and look at the original problem. It was right here.
Mm-hmm.
And when you're writing it in that vertical format, we're just going to, when you're looking at the problem, we had that negative, negative. We're going to write it as a positive. We're going to write it out distributed as we go. So we'll have that 5y to the second minus the yz. And we put them right under each other. So that we, see, these are like terms. And these are like terms. So we'll put them under their like terms as we write them down. Plus 7z squared. Then, so we're actually organizing them so we don't have to look for them afterwards.
Okay.
So then we'll still get the same answer. This here will become...
5y squared.
And that one will come...
5y squared. Z. And then 4z squared.
Yes. And you're going to get the same answer.
That was just faster.
You like this one better.
Uh-huh.
Okay. Now, the part that seemed a little faster is because we had already distributed this.
Mm-hmm.
And if you look on this one, when they wrote them under, they didn't have them all. There's nothing to write, so they just put space. And that's okay. You just have to analyze it. You're kind of like doing the combining of the like terms and organizing it before you do it. So this is similar to when you used to do 2 plus 5 on top as to 2 plus 5. You can write them either way.
Right.
Okay. All right?
Okay.
So that's subtracting polynomials.
It really is. It's no different from the other one, really.
Right.